Imagine, for a moment, that we've sent something into the vast, uncharted stretches of space, something that is still, against all odds, traveling, silently drifting through the stars. Voyager 1, launched in 1977, has now traveled an unimaginable 22 billion kilometers from Earth. That's 22 billion kilometers in over 40 years, at a speed of roughly 62,140 kilometers per hour. This tiny, unassuming spacecraft, once the size of a minivan, is now humanity's farthest-reaching ambassador to the cosmos. It is moving further away from us with each passing moment, taking with it the hopes of discovering new mysteries beyond our solar system, to a place where no human-made object has ventured before. The burning question is, just how far can Voyager 1 go? Could this spacecraft, one day, reach a distant star system? Is it possible that we might one day receive a message from there, the first ever communication from an alien civilization? Voyager 1, along with its twin, Voyager 2, are not just space probes, they are the very milestones in our quest for understanding the universe. These probes have given us images and data that once seemed unimaginable, images of the outer planets in our solar system, along with their moons, rings, and magnetic fields. The revelations were supposed to be the culmination of their mission, the end of their journey. But instead, something extraordinary happened. The mission, initially intended to last a few years, has continued well beyond expectations, and here we are, over 45 years later, still receiving data from these probes. They are still sending back information, still exploring space, still living on. It's almost like these spacecraft have become time capsules, silent witnesses of human ingenuity. What makes Voyager 1's journey so remarkable is that, after all this time, it is still traveling outward, deeper and deeper into the great unknown. In fact, Voyager 1 crossed the boundaries of our solar system in 2012. It was the first man-made object to leave the protective bubble created by our sun's influence, known as the heliosphere, and enter interstellar space. This is an achievement that most of us never thought would happen, and yet it did. Voyager 1 didn't stop there. It continued, relentlessly pushing further into the cosmos, far beyond the reach of human control and oversight. To give you an idea of the scale, just think about how far Earth is from the Sun. That distance, which is about 150 million kilometers, is known as an astronomical unit, AU. Voyager 1, as of the most recent calculations, is more than 150 Australian dollars from Earth. It's more than 22 billion kilometers away and is still moving at an incredible speed, but the question arises, what lies beyond this? When Voyager 1 passed the edge of our solar system, crossing what is known as the heliopause in 2012, it ventured into a region that was largely unknown to humanity. The heliopause marks the point at which the sun's solar wind, a continuous stream of charged particles, slows down and merges with the interstellar medium, the matter and radiation that exists between stars and the galaxy. For all of human history, this boundary has been like an invisible wall that protected us from the unknown. But now, Voyager 1 had crossed it, and it began sending back data that was nothing short of revolutionary. The transition from the solar wind to the interstellar medium was not a smooth, gradual change as scientists had anticipated. Instead, Voyager 1 encountered a sharp, abrupt transition, a kind of barrier that seemed to have a thickness. It was unlike anything we had predicted based on previous simulations. This discovery raised new questions about the nature of interstellar space and how our solar system interacts with the rest of the universe. What was truly surprising was that, despite expectations of a nearly empty space beyond our solar system, Voyager 1 found that the interstellar medium was not as sparse as once thought. There were still particles present, and they were more abundant than scientists had originally anticipated. This observation suggested that the boundary between our solar system and interstellar space is not a thin, easily crossed line, but rather a much more complex environment than we had understood. Voyager 1 had provided humanity with the first real measurements of the environment beyond the sun's influence, and in doing so, it had expanded our understanding of the universe in ways that were previously unimaginable. What came next was another shock, this time, the discovery of what was later referred to as the wall. Even as the density of particles dropped dramatically, there were still more particles than scientists had expected. Voyager 1's data indicated a kind of buildup of particles and radiation just inside the boundary of interstellar space. This phenomenon suggested that, rather than space being a vacuum, there might be far more going on in the cosmos than we had realized. The interaction between the solar wind and the interstellar medium could create a kind of dense barrier around our solar system, altering the properties of space in ways that had never been observed before. Voyager 2, its twin, confirmed these findings when it made its own journey into interstellar space, just a few years later. While Voyager 1's mission was initially meant to study the outer planets in our solar system, its success in venturing beyond the reach of the Sun's influence opened up an entirely new chapter in our exploration of space. The discovery of the heliopause, the transition to the interstellar medium, and the unexpected wall have raised new questions about our understanding of space itself. For decades, we had no idea what lay beyond the edge of our solar system. We knew the planets and their moons, the rings and the comets, but once the Voyagers left that known frontier, all bets were off. The reality of what they were encountering was so much more complex than we ever imagined. But let's take a step back and understand the true engineering marvels that made this possible. When the Voyager probes were first designed, they were built with a level of durability that was almost unheard of at the time. Engineers were faced with the challenge of sending a spacecraft beyond the realm of human control, beyond the reach of Earth-based support. They needed to ensure that these probes would continue to function without constant maintenance, and that they would be able to withstand the extreme conditions of space. To do this, they used materials known for their toughness, like aluminum and titanium, to create the durable, multi-sided body of the probes. These materials have served the probes well, protecting them from the radiation and extreme temperatures of space for decades. Perhaps the most iconic feature of the Voyager probes is their large, dish-shaped high-gain antenna, which measures 3.7 meters across. This antenna allows Voyager 1 to stay in contact with Earth, even at the vast distances it has traveled. It is positioned so that it is always pointing toward Earth, sending data back to us using radio waves. As the probes venture further into space, the signals take longer to reach us. A message that once took mere minutes to travel to Earth now takes more than 20 hours. But despite the incredible distance, the communication continues. The signals are received by NASA's Deep Space Network, a group of 3 giant antennas located in California, Spain, and Australia, which are specifically designed to pick up signals from spacecraft that are far beyond our planet's reach. Without this network, it would be impossible to maintain contact with the Voyager probes as they journey through the vastness of space. Even though Voyager 1 has been traveling through space for more than 45 years, its communication with Earth has not slowed down. The engineers at NASA had initially been unsure if they would be able to maintain contact with the probes once they left the outer planets. The distance, combined with the harsh conditions of space, posed a significant challenge. However, thanks to the durability of the probes and the ingenuity of the engineers who built them, Voyager 1's radio contact has remained strong. The signals, traveling at nearly the speed of light, still make their way across the cosmos to be received by the Deep Space Network. As the years have gone by, many of the scientific instruments aboard Voyager 1 have been powered down to conserve energy. These instruments, which were designed to gather data about the planets, the moons, the magnetic fields, and the composition of space, have now largely been inactive for years. But even without these instruments, Voyager 1 still provides valuable data about the interstellar environment. It continues to measure the density of particles, the magnetic fields, and the radiation that permeates space, giving us a glimpse into the unknown. And as long as its radioisotope thermoelectric generator, RTG, which converts the heat from the decay of plutonium-238 into electricity, continues to function, Voyager 1 will keep sending these signals back to Earth. This power source is expected to last for several more years, with scientists predicting that communication with the spacecraft will likely cease around the year 2030, when its power levels drop too low to maintain contact. So, what happens next? How far can Voyager 1 continue its journey? The reality is that no one truly knows. After it loses contact with Earth, Voyager 1 will continue to coast through space in its trajectory, drifting toward distant stars. But these stars are so far away that it could take thousands of years for Voyager 1 to even pass within a few light-years of them. In fact, calculations suggest that its closest approach to any star system could happen in roughly 40,000 years, when it will pass by a star known as Gliese 445 in the constellation Camelopardalis, or Giraffe. Even then, the encounter will be so distant that it's unlikely that anything on the star system will even notice the passing spacecraft. After that, Voyager 1 will continue on its course, heading toward the constellation Lyra, where it will pass near the star Ross 428 in about 1.3 million years. Though it may seem like an eternity, Voyager 1's journey will eventually come to an end. The harsh conditions of space, including the radiation and the extreme cold of interstellar space, temperatures nearing absolute zero, will begin to degrade the spacecraft over time. Its instruments and systems will slowly succumb to the wear and tear of the environment. It's likely that in a few 100,000 years, the spacecraft will break apart, its parts slowly disintegrating into space dust. But even as it falls apart, parts of Voyager 1 might still travel through space as recognizable artifacts of human engineering, potentially for millions of years to come. The possibility of Voyager 1 encountering another civilization is something that often captures our imagination. While the chances of this happening are astronomically slim, it's not completely out of the question. If a more advanced civilization were ever to explore the universe, it's conceivable that they might come across Voyager 1, now a relic of an ancient civilization that existed on a small, blue planet orbiting an average star. Inside the spacecraft, they would find the Golden Record, a phonograph record that contains sounds and images designed to represent life on Earth. The record contains greetings in 55 languages, a variety of music from different cultures, and even a message from the President of the United States at the time, Jimmy Carter. If an alien civilization were to find this record, it would be a powerful symbol of the curiosity and ambition of humanity, a message from one species to the cosmos, offering a glimpse into our existence. Even if we never encounter another civilization, the Voyager probes will continue their journey long after we are gone. Their legacy will be one of exploration and discovery, a testament to the ingenuity and determination of the human spirit. Whether or not we ever receive an answer from the stars, we have already made history. The Voyager probes have traveled farther than any human-made objects ever, and they continue to teach us about the universe and our place within it. In the end, Voyager 1 might just become our longest-lasting ambassador, traveling through the cosmos, carrying the hopes and dreams of humanity with it for millions, even billions, of years. Who knows what we might discover through its journey, whether it be a distant star system or the lingering traces of an alien civilization, the possibilities are truly infinite.